Hello everyone, my name is Khaled Medini. I'm an associate professor of industrial engineering at Saint-Étienne. And today's presentation is about our paper titled Configurators as a Means to Leverage Customer-Centric Sustainable Systems, Evidence from the 3D Printing Domain. This paper is co-authored with Maxence Rousseau from Saint-Étienne, David Romero from ITES, and Thorsten Wuest from West Virginia University. So today we'll have a look at the problem statement and research context with a focus on the SUSTAIN project research framework. Afterwards, we'll provide some insights into product service configurators and into 3D printing. Then we'll move to the case study about 3D benchmark model configuration before moving to discussion and perspectives. 1 century ago, Ford managed to invade markets with the affordable and efficient Model T. However, Ford was able to provide any color you want as long as it is black. That is kind of very limited choice options. This was consistent with the volume-oriented production aiming to increase efficacy and efficiency. So in other terms, the focus was put on mass production. However, the evolving customer requirements in both business-to-business and business-to-customer situations led to higher offering variety. The problem is that high variety goes hand in hand with operations complexity and potential negative impact on sustainability. The aim of SUSTAIN project is to steer variety and complexity in operations management towards more sustainability. SUSTAIN project is a Franco-American project whose ambition is to unleash the benefits resulting from the synergies between customer-centric projects and operations management and sustainability. The backbone is the use of configurators to address these problems. The research framework provides a foundation to address the integration of sustainability consideration in managing the variety of the products and services. It relies on 3-step process to maintain the whole system operations. The steps are as follows. On the right-hand side of the figure, the capturing customer requirements step, and it involves first, clear definition of the solution space to meet customer requirements, supporting choice navigation, capturing preferences of the customer regarding economic and environmental perspectives of his configured solution. Second step, which is in the middle, is about maintaining and updating configurator data and managing the quotation process. And the third step on the left-hand side of the figure is about managing the product or service portfolio and variety. And this includes, for example, cost estimation, modeling and estimation techniques using lightweight financial models, simplified lifecycle assessment, carbon footprint indicators, and some methods such as multi-criteria decision-making in order to address some problems in deciding based on high number of indicators. One of the basic components, which is also seen as the backbone of the SUSTAIN research framework, are the configurators, which can be defined as knowledge-based systems supporting user in creating personalized products by specifying modules, functionalities, and so on. The figure shows on the right-hand side of the slide shows a generic value chain of a manufacturing company, including its specification process from the research conducted by Bonnev, Corel, and Pham. This figure highlights the potential of configurators in supporting the adaptation of product and service to customer needs. And in the second figure, left-hand side in the slide, an example from the T-Shirt Studio website. It illustrates the possible options that can be selected by customer and which reflect his preferences. While this example integrates one environmental friendly t-shirt option, it does not necessarily support the assessment of customer choices from an environmental perspective, which is generally a predominant figure with the quotation processes of online configurators, which mainly inform customer of price and possibly lead time rather than other value-related criteria. Let us now move to some insights into 3D printing, which became a production method in its own right and which even challenges traditional manufacturing methods. As a result, many online 3D printing services are now available. Many of them are free. And among the most common materials used for 3D printing is PLA, which refers to polylactic acid, which is a bioplastic generally derived from corn scratch, sugar, cane, beet. And it became very quickly the most widely used filament because of some features, such as the fact that it is easy to print and it melts at low temperatures. Among the most impacting parameters on the comparative costs of 3D printing is the used material, but also cost of quality, such as failed printing, electricity, operation cost, and so on. So it's very important to consider these factors in costing the 3D printing process. Right-hand side of the figure shows an example of the use of Craft Cloud, which is currently listed as the cheapest 3D printing service provider. It offers the printing of different materials, of models with different materials, and it can be used as a basis for assessing the results from the case study developed in the current research. The aim of the case study is to provide a proof of concept, and it involves the 3D benching model, which is designed to offer a wide range of challenging geometric features for 3D printers, and it helps addressing several issues related to additive manufacturing, as it helps revealing typical problems with surface finishing, model accuracy. So the implementation of the configurator concept was done using Visual Basic, and on the left-hand side of the slide, we show the architecture of the configurator. So there is a guided user interface which supports customer in configuring the 3D benching model. Main options implemented so far include quality level, filling rate selection. The configuration chosen by the customer is stored in a local modeling database with several attributes reflecting the customer choices. The configuration guided user interface feeds a model to calculate environmental and economic indicators. These are shown in a result guided user interface, the right-hand side of the figure. The calculation of economic indicators is based on the cost categories that we mentioned before, and the calculation of environmental indicators, CO2 for instance, is supported by an extraction from an environmental database in order to compute the CO2 equivalent impact of the selected configuration. These results are shown according to different time spans, like for example 20 years, 100 years, 500 years, in order to allow the customer see the impact from an environmental point of view of his configuration decision. In terms of economic assessment, according to customer profile, we may either show the cost or price, including value-added taxes. So this is kind of illustration of the concept of the configurator and the kind of the results we shall expect from the configurator putting together economic and environmental aspects of sustainability. Good. So the aim of this research is to fill the gap related to environmental sustainability into business, and most importantly, on a win-win basis. To this end, the objective of the current paper is to frame a strategy that truly incorporates sustainability as an equal pillar in business development. Recent endeavors in this sense include some European projects, for example, within the FP7 program, for example, SMC, Sustainable Mass Customization for Sustainability. The SUSTAIN project, funded by FACE Foundation through the Thomas Jefferson Fund, lands itself in this continuum. The research being conducted within the framework of SUSTAIN is, let's say, expected to shift from the figure of indecisiveness regarding sustainability actions, left-hand side figure here in this slide, towards a customer-centric sustainable project and operations management, right-hand side figure of the slide, and ultimately supports a more harmonious development. Ongoing research includes refinement of the conceptual and technical integration of the guidelines and methods for capturing customer requirements, managing the quotation process, and also using this information to manage product and service variety and portfolio as a whole. That's it for today. Thank you for your attention. Please feel free to read the full paper. I want also to mention that there is an ongoing special issue involving 3 of the 4 authors of the current paper, and of course contributions are very welcome. For any question, please do not hesitate to email us. Thank you again.